So we've known for a long time that aerosol particles form clouds, that every cloud droplet forms on what we call an aerosol particle. It wasn't until the 1990s that we really started to understand that this actually could be a significant effect on climate from human-produced aerosols, anthropogenic aerosols as we call them.
So this idea of MCB, or Marine Cloud Brightening, is the idea that when you introduce additional particles, extra particles, we call aerosols, in the vicinity of clouds, they act to make the clouds more reflective. What we don't know is how much more reflective. That's much harder to quantify. So the question is whether these techniques can be used to brighten clouds sufficiently to be a factor in operating to cool the planet.
We're focused on trying to understand whether marine cloud brightening is even a feasible way of slowing climate warming, and if you did it, what would be the full suite of impacts. The latest big climate assessment report from the Intergovernmental Panel on Climate Change has shown us that even with significant amounts of mitigation of emissions in the coming years, we're going to have a significant amount of climate warming for a few decades at least, even with significant emissions reductions. So that means that we're going to have to do some amount of adaptation to climate change, and that it's likely that people are going to start considering wanting to reduce the amount of heat in the climate system to reduce climate impacts, especially once climate impacts become more significant.
The project came together in a pretty interesting way. Rob Wood, my colleague, was involved in some early studies with a scientist named John Latham. And they had talked about this idea of marine cloud brightening. And Rob came to me and said, how about if you work with me on this project? Then a colleague of mine organized a conference in California to talk about the ethics of climate engineering. I came back from that meeting and I said to Rob, okay, I'm in, because there are people who are talking about doing this who don't understand what they're talking about, and it's pretty scary, and we need scientific input to understand what should be done, could be done, or shouldn't and couldn't be done.
To test whether we could brighten clouds in over a sufficiently large area of the ocean and under a wide range of meteorological conditions, we're using models on different scales. But the simulations that we're using to really get at the cloud physics and the cloud dynamical changes are what we call large eddy simulations. These are simulations where we're actually representing the turbulent motions in the clouds, and we're able to use those to introduce particles into them, have a representation of what we call aerosol cloud interactions. That is how the clouds and aerosols interact with each other, and we're able to then change how many particles we introduce into the clouds. We're able to change the meteorological conditions, and we can span a wide range of what we will call phase space of meteorological conditions to try and test the extent to which we would be able to brighten clouds in different meteorological conditions.
The higher resolution models contain a lot of complexity about how clouds respond to particles and meteorology. But they're of course not perfect. None of these models are perfect. And the only way to know if the physical processes in those models are correctly represented is to test them against observations. The field studies that we're wanting to do under the Marine Cloud Brightening Project are really similar to field studies we've done in the past. And in those studies, what we've done is go out and sort of passively try and study how particulate pollution, inadvertent particulate pollution emissions, are affecting cloud properties. So what we would be getting to do with Marine Cloud Brightening is basically a controlled experiment, a controlled field test, where we're taking sea salt and spraying it into the clouds and seeing how the clouds change in that location versus what the clouds look like nearby. So it would be very similar to what we've done in the past, but in this case, a controlled experiment, which of course is the ideal for doing science research, is getting to do a controlled experiment.
Like all climate science, marine cloud brightening is itself very interdisciplinary as a course of research. We need to understand from an engineering perspective how we actually create those particles, and can we create enough of those particles. And then the work that I'm doing at the University of Washington is focused on the cloud physics. Then we want to understand, if we could brighten these clouds, what would happen if we did implementation to the climate system? Would we get changes in precipitation patterns? Would there be changes potentially in ecosystems in the ocean due to changing sunlight? So there's a whole range of disciplines need to be involved in this, and they all need to talk to each other, because there are things we can learn from the high resolution modeling that informs the engineering. To understand the potential for marine cloud brightening, we have to understand these aerosol cloud interactions, which are fundamentally one of the main sources of uncertainty in predicting future climate, because these inadvertent impacts on clouds are one of the major sources of uncertainty. So the science involved in marine cloud brightening is very similar. We call this dual purpose. In other words, learning about the potential for climate intervention from marine cloud brightening actually would provide us a lot of information that we need to understand how much we're currently brightening clouds.
We are eager to continue to do work in this area, and given the changes that we're seeing to climate today and to the difficulty of finding ways to ramp down as rapidly as possible the emission of greenhouse gases, of carbon dioxide, we believe that there's some urgency to studying this kind of a problem.